Here is another brilliant examination style question for high school students taking functions, which is a prerequisite for calculus. We are going to solve a quadratic equation and then we have a related question of splitting into two fractions. The question here is, consider equation ax squared plus 7x minus 2a equals to 0 that has two distinct solutions for x. Given that x equals to minus 3 is a solution of ax squared plus 7x minus 2a equals to 0, find the value of a and the other solution of x. Hence, express 5x minus 7 over ax squared plus 7x minus 2a as sum of two fractions. Beautiful question where we need to apply concepts learned in different chapters. Great. I'm Anil Kumar. Welcome to my YouTube channel. We've been here for the last 15 years. Excellent learning platform for our students. We learn by sharing. This question has been shared by one of my IBHL student. Now let's see, how do we solve this equation? We are given a quadratic equation which is ax squared plus 7x minus 2a, and also given that there is x equals to minus 3 as a solution. It means that if I substitute minus 3 in the equation, I should get 0, right? So let's work on that. So we have ax squared plus 7x minus 2a equals to 0. This equation is satisfied when we put x equals to minus 3. So let's do it. So a times minus 3 squared plus 7 times minus 3 minus 2a equals to 0. Now you can see only a is there, one unknown, which we can find. So 9 is minus 3 squared plus becomes minus when I multiply 7 and minus 3. So minus 21 minus 2a equals to 0. So 9a minus 2a will be 7a. So 7a is 21 and therefore a is 21 over 7, which is 3. So once we know what a is, we can factor the quadratic equation and find the other root. So let's write down the equation now. A is 3, therefore the equation is 3x squared plus 7x minus 2 times 3. Let me write 2 times 3 here, right? Equals to 0, 2 times 3. So we have 3x squared plus 7x minus 6 equals to 0. So you're looking for product and sum. We can also do direct factoring. However, I'll walk you through these steps. So the two numbers which can give us sum of 7 will be, actually speaking, minus. So we are looking for two numbers whose product should be 3 times minus 6, which is minus 18, and the sum should be plus 7. So 6 times 3 will not work, but 9 times 2 will work, right? So we could split this as 3x squared plus 9x minus 2x minus 6 equals to 0. From the first two terms, we can take 3x as a common factor. So we get x plus 3. And here 2 is common factor, minus 2 rather. And x plus 3, as you can see, can be factored out with 3x minus 2. Well, x plus 3 was expected factor since we have given the root. So what you need to do is equate the second factor to 0 to find the other root for this parabola, right? So 3x minus 2 equals to 0 gives us what? Let's write down 3x minus 2 equals to 0. That gives us 3x equals to 2, or we get the solution x equals to 2 by 3. Makes sense. So x equals to 2 by 3 is the second solution of this particular equation. Correct? So now what we can do is we can write ax squared plus 7x minus 2a equals to 0 as product of these two factors. One is x plus 3 and the other one is 3x minus 2. So that becomes the equivalent equation for the given one, right? So I hope up till now everything is absolutely clear, right? Now we come to the second part where we are given 5x minus 7 over ax squared plus 7x minus 2a, the same quadratic equation. We need to split it into two fractions. Let us see how do we do that. Right, so 3x, I'll copy the solution there on the next page and then we'll continue, correct? So x plus 3 and 3x minus 2 are the two factors. So this equation which we wrote is actually x plus 3 into 2x 2x minus, let's see that again, 3x minus 2. 3x minus 2 equals to 0. So one root is x equals to minus 3, already given to you. The second one is 2 over 3. Correct. Now let's look into the second part, which is we are given 5x minus 7 over ax squared plus 7x minus 2a. However, we found what the denominator is. It is 5x minus 7 over. So we have this expression which is x plus 3 times 3x minus 2. So that's a rational function. We need to write this rational function as two fractions, right? Two rational functions. So the method is 5x minus 7 over, we have got two linear factors, right? So we can write this as a over the first factor, which is x plus 3 plus b over 3x minus 2. Make sense? So that is how we have to split it. Now basically we need to find the value for a and b. How do we do that? Well, let's take a common denominator and continue. So we have a common denominator which is x plus 3 times 3x minus 2. So when you multiply, a gets multiplied with 3x minus 2 and b gets multiplied with x plus 3. Make sense? Correct. And all this is actually equal to 5x minus 7 over ax squared plus 7x minus 2a. Perfect. Now, if I expand this, then we get what? So a times 3x means we have got 3ax minus 2a plus bx plus 3b over the denominator, which is x plus 3, 3x minus 2. So what you notice here is that we have a term which is constant. We also have a term which is x in it, right? So what we will do is the constant term, which is minus 2a plus 3b, will be equated to minus 7, right? And the other term with the variable will be equated to 5x, and that gives us two equations, correct? So let me rewrite this. So we have 3ax plus bx, and this is equal to 5x. Makes sense, right? The other term is minus 2a plus 3b, and that is equal to minus 7. You see how we get two different equations to work with. Now, a and b are two unknowns, and there are two equations, and therefore we can easily solve this. Perfect. You can actually pause the video, answer, and then look into my suggestions, right? So let's solve them. So we have 3ax plus bx equals to 5x. Let's write down 3ax plus bx equals to 5x. That's the first equation. And what is the second one? Minus 2a plus 3b equals to minus 7. Minus 2a plus 3b equals to minus 7. So these are the two equations. Great. Now, you can adopt any method you want. And in the first equation, as you can see, the x components will cancel. So we are left with 3a plus b equals to 5. Correct? And from here, we can say what b is and substitute in the other equation. This is one way of doing it. Let's do that way. So b is equal to 5 minus 3a. Correct. Now in the second equation, what we are going to do is substitute this value of b, because minus 2a plus 3 times 5 minus 3a, and that should be equal to minus 7. So minus 2a plus 15 minus 3 times 3, 9a equals to minus 7. Combining a is minus 11a, and taking 15 on the other side, we get minus 7 minus 15. So we get minus 11a equals to minus 22, or a equals to 22 by 11, which is 2. So we get the value of a as 2. Perfect. Once we get the value of a as 2, substitute into this equation b. We got 5 minus 3 times 2. So b equals to 5 minus 6, which is minus 1. Correct? So we get two solutions. And now, as you can see, we can write down as two fractions, right? So this is basically equal to what? A is 2, so it is equals to 2 over the first factor, right? And what was that? That was, let's see, first factor was x plus 3, right? And the second is 3x minus 2, right? So first is x plus 3, and b is negative 1, so we write negative 1 over 3x minus 2. So that becomes the solution for the given question. You see how we have solved it. So once again, first, once we know a root, we can find the second root by first getting the value of a. And once we have a, and the two roots, which are the factors, can be now treated as a over one factor plus b over the other factor. Now in the numerator, you can equate the x terms, the variable terms, and the constant terms to get two different equations. Solving these two equations, we get the solution for writing the rational expression as sum of two fractions. Makes sense? That's great. Perfect. Watch our playlist for more, contribute, and if you have any questions, you can always write down in the comments normally. I answer the questions within 48 hours. Feel free to write your comments and share your views. Have a great day. Thank you.